Hello students. Hello and welcome to this video. In this video, we will solve question number 51 to 60. So as you can see that from 46, we have divisibility questions. We have solved 5 questions on divisibility, and next 10 questions will be also on divisibility. So we'll go a bit fast here, okay? Now the link to download the PDF will be in description. As well as at the end, I will show you how you can maintain an updated copy of the books. And I will show you my website where you can come and ask questions related to math. So without further ado, let's get started. Question 51 says that show that if n is in the set of natural numbers, 5 times 2 raised to the power 3n minus 2 plus 3 raised to the power 3n minus 1 is divisible by 19. So we let Pn is equal to given expression, we substitute n is equal to 1. We get 5 into 2 plus 3 square, that is 19, which is divisible by 19. So the statement is true for n is equal to 1. We let it be true for n is equal to m. And then we have p of n is equal to 5 into 2 raised to the power 3m minus 2 plus 3 raised to the power 3m minus 1 is equal to 19k, where k is in the set of natural numbers. Now we write for pm plus 1. So it becomes 5 into 2 raised to the power 3m plus 1 plus 3 raised to the power 3m plus 2. So we take out the power 3 because we want to get the form of pm. So this becomes 40 into 2 raised to the power 3m minus 2 plus 27 into 3 raised to the power 3m minus 1. So we take 8 out of this, that is 5 into 2 raised to the power 3m minus 2 plus 3 raised to the power 3m minus 1 plus 19 into 3 raised to the power 3m minus 1. So this was our 19k. So we got 8 times 19k plus 19 times 3 raised to the power 3m minus 1, which is divisible by 19, and hence by induction we have the result. Question 52 is similar. This time we have 7 raised to the power 2n plus 2 raised to the power 3n minus 1 times 3 raised to the power n minus 1 is divisible by 25. So as usual, we let it be equal to Pn, and we substitute n is equal to 1. We get 7 square plus 2 raised to the power 0 plus 3 raised to the power 0, which is equal to 50, divisible by 25, and that's why the statement is true for n is equal to 1. We let it be true for n is equal to m. So we have 7 raised to the power 2m plus 2 raised to the power 3m minus 1 times 3 raised to the power m minus 1 is equal to 25k, where k will be in the set of natural numbers. Now we compute m plus 1. We get 7 raised to the power 2m plus 2, 2 raised to the power 3m, and 3 raised to the power m. So we want this power, so we take out 7 square, we have got 49, and we want 3m to the power minus 3 and m minus 1. So we do that, and then we have 24 here. Now this is equal to 25 into 7 to the power 2m plus 24 into 25k, which is divisible by 25, and hence by induction we have the result. Question 53, the expression in this case is 10 to the power n plus 3 times 4 raised to the power n plus 2 plus 5, and the divisibility is with 9. So like previous, we let it be Pn, we substitute n is equal to 1, we get 10 plus 3 times 4 to the power n 3 plus 5, which is equal to 207, which is divisible by 9, and hence the statement is true for n is equal to 1. We let it be true for n is equal to m. So we have got 10m plus 3 times 4 raised to the power m plus 2 plus 5 is equal to 9k. Next we put n is equal to n plus 1. We get 10 raised to the power m plus 1 plus 3 times 4 raised to the power m plus 3 plus 5. So we want 10 raised to the power m, so we got 10 out here, and we want 10 plus 2, so we have got 12 here. Okay, now we substitute for 9k, and we will have 10 into 9k plus 9 times 10 to the power m plus 9 times 4a to the power m plus 2, which is divisible by 9. And hence, by induction, we have the result. Question 54, the expression this time is 3 raised to the power 4n plus 2 plus 5 raised to the power 2n plus 1. And divisibility is with 14. So we let Pn is equal to given expression. We put n is equal to 1. We get 3 raised to the power 6 plus 5 raised to the power 3, which is 854, which is divisible by 14. And hence the statement is Q for n is equal to m1. Now we let it be Q for n is equal to m. So 3 raised to the power 4m plus 2, 5 raised to the power 2m plus 1 is equal to 14k. Now for m plus 1, we will have here 4m plus 6. And here we will have 2m plus 3. So we want power of 4m plus 2. So we take 3 raised to the power 4 out. That is 81. And for this, we take power 2 out. We got 25. Once we have that, we substitute for 14k here. So we get 25 into 14k plus 56 times 3 raised to the power 4m plus 2, which is divisible by 14 because 56 is divisible by 14. And hence, by induction, we have the result. Question 55, the expression this time is 3 raised to the power 2n plus 2 minus 8n minus 9. And divisibility criteria is with 6n. So we let Pn is equal to given expression. We put n is equal to 1. We get 3 raised to the power 4 minus 8 into 1 minus 9. That is 64, which is divisible by 64. And hence it is true for n is equal to 1. We let it be true for n is equal to m. So we have got 3 raised to the power 2n plus 2 minus 8n minus 9. That is 9 raised to the power m plus 1 minus 8m minus 9. That is equivalent to 9 into 9 to the power m minus 8m minus 9 is equal to 64k, where k will be in the set of natural numbers. Now we compute Pm plus 1. So we get 3 raised to the power 2m plus 4 minus 8 times m plus 1 minus 9. So we rewrite it as 9m to the power m plus 2 minus 8m minus 17, which is equivalent to 81 into 9 to the power m minus 8m minus 17, which is equal to 64k plus 72 into 9 to the power m minus 8, which is equal to 64k plus 8, 9 to the power m plus 1 minus 1. Now we'll prove that 9 to the power m plus 1 is minus 1 is divisible by 8. We let Qn is equal to so and so, and we put n is equal to 1. We get 80, which is divisible by 8. Let it be true for n is equal to r. We get 9 raised to the power r plus 1 minus 1 is equal to 8s, whereas in the set of natural numbers. So qr plus 1 is 9 times 9 raised to the power r plus 1 minus 1, which is equal to 8 into 8 to the power r plus 1 plus 8s, which is divisible by 8, and hence by induction we have the proof. Question 56 says that n raised to the power 7 minus n is divisible by 7. So we put n is equal to 1, we get 1 raised to the power 7 minus 1 is equal to 0. So it is true for n is equal to 1. Now we let n is equal to m. So n raised to the power 7 minus m is equal to 7k. We compute Pm plus 1, that is m plus 1 raised to the power 7 minus m plus 1. We get m to the power 7 plus 7c1 plus times n raised to the power 6 and so on. This is the binomial expansion. Okay, and we get minus m minus 1. So this one will get cancelled. Now this will be m to the power 7 minus m. Now this will be all contain factor of 7, and thus we have 7k plus 7s, whereas in the set of natural numbers, which is divisible by 7, and hence by induction we have the result. Question 57 is 11 raised to the power n plus 2 plus 12 raised to the power 2n plus 1, and divisibility condition is by 133. So again, we put n is equal to 1, we get 11 cube plus 12 cube, which is equal to 3059, which is divisible by 133. So the statement is true for n is equal to 1. Let it be true for n is equal to m. So we have 11 raised to the power m plus 2 plus 12 raised to the power 2n plus 1 is equal to 133. Now we compute n plus 1, it would be 11 times 11 raised to the power n plus 2 plus 144 times 12 raised to the power 2 n plus 1. We have taken 12 square out and 11 out. Now this entire thing is 11 into 133k plus 133 times 12 raised to the power 2 n plus 1, which is divisible by 133, and hence by induction we have the result. Now we move on to question 58, which says that 10 raised to the power 2n minus 1 plus 1 is divisible by 11. So we put n is equal to 1, we get 11, which is divisible by 11. Now Pm is 10 raised to the power 2n minus 1 plus 1 is equal to 11k. Now we put m plus 1, we get 10 raised to the power 2n plus 1, which is equal to 100 times 10 raised to the power 2n minus 1 plus 1, which is equal to 99 times 10 raised to the power 2n minus 1 plus 11k, which is divisible by 11. Question 59 says that this time we have 7 raised to the power n minus 3 raised to the power n, and divisibility is by 4. So we put n is equal to 1, we get 4, and we let it be true for n is equal to m. 7 raised to the power m minus 3 raised to the power n is equal to 4k. We put n is equal to n plus 1, 7 raised to the power n plus 1 minus 3 raised to the power n plus 1. We take out 7 and 3 here, we get 7 times 7 to the power m minus 3 times 3 to the power m, which is equal to 4 times 7 to the power m plus 3 into 4k, which is divisible by 4, and hence by induction we have the result. For question 60, the expression is 2 times 7 to the power n plus 3 times 5 to the power n minus 5, and divisibility is by 24. We put n is equal to 1, we get 24, which is divisible by 24. Now we put n is equal to m, we have 2 times 7 to the power m plus 3 times 5 to the power m minus 5 equal to 24k. We put n is equal to n plus 1, we have got 2 times 7 to the power m plus 1 plus 3 raised to the power 3 times 5 raised to the power m plus 1 minus 5. We take out 7 common out here, and we take out 5 here. We get 14 times 7 to the power m plus 15 times 5 to the power m minus 5, which is equal to 4 times 7 to the power m plus 5 times 24k plus 20, which is equal to 4 times 7 to the power m plus 5 plus 120k. Now we'll prove that 7 to the power m plus 5 is divisible by 4. So that 6. So that 6 into 4 is 24. Now we let Qn is equal to 7n plus 5. Put n is equal to 1, it is 12, so divisible by 6. We let it be true for n is equal to m. 7 raised to the power n plus 5 is equal to 6s. Now we put n is equal to m plus 1, we get 7n plus 1 plus 5, which is equal to 6 times 7 to the power n plus 6s, which is divisible by 6, and hence by induction we have proven the result. Now I'll show you my website, ashtavakra.org. You can come and download algebra, trigonometry, and coordinate geometry from second, third, and fourth link. Note that the downloaded PDF will not have the date, so you need to put this date in the file, so that when you come back again, say after 15-30 days, you will see that the PDF has been updated and you can download them with PDF. For example, I will update algebra very soon in a day or two, so you can download the date again, PDF again. The reason for not having date in the PDF is that I will have to go and update all the links, and if you share the link with anyone, it will become invalid. That's why the link does not contain the date. If you want to ask questions, you can come to website to punjika.astrotalk.org. You can click this 8th link, and you can come on and ask me a question here. Mathematical symbols are supported using MathJets. You can use tag of algebra, calculus, geometry, coordinate geometry, trigonometry, and probability. So I should be able to answer your question here. That is, if I know. And if I don't know, I'll try to find the answer. I'll try to solve it and then give you the answer. So with this, we come to the end of this video. In the next video, we will solve 10 more questions. Those are also divisibility questions. Okay, so many questions are for practice only. There is no other reason. And I hope that you have enjoyed this video. The questions are repetitive in nature, but that's how you develop muscle memory. Okay. So with this, I will end this video. I hope that you are finding this video useful and informative for your studies. If you have not watched other videos in the playlist, I suggest that you go ahead and watch the entire playlist. There are lots of problems which have been solved. So that is good for practice. And I'll see you in the next video tomorrow with 10 more problems on mathematical induction. I'll take my leave here. You have a great day and enjoy.